A group of astronomers say that they've seen a monster galaxy, 12.4 billion light years away, and discovered details that were previously unknown. It's all detailed in a recent study, which found a far more ordered galaxy than previously thought. But what is a monster galaxy? That's one of the many answers I sought from Min Yoon, one of the study's authors and a University of Massachusetts Amherst astronomy professor.
Monster galaxy is a galaxy that, as the name goes, really big. So galaxies come in all kinds of sizes. Our Milky Way galaxy is on the big side. Anything bigger than Milky Way we get kind of excited about. This particular galaxy weighs about 10 times more than the Milky Way. And it's very...
This is a huge discovery for you and the team, correct?
Well, it's an unexpected, exciting discovery for us, yes.
And so then how exactly did you discover it?
It was a bit of a stumbling into it initially. We had to discover something, you have to build a new instrument. So we built a new instrument, we did the search. We had a pretty good idea there would be interesting things out there. We just didn't know exactly it was going to turn into a monster galaxy, but it did, which is very exciting. We're always, keeping our fingers crossed. That would have been the best case scenario.
Yeah. So even bigger and wilder than you could kind of imagine?
Absolutely. Because we have a pretty good idea how the universe came about, how the galaxies came about. And that popular picture does not really include a monster galaxy like this one so early in the universe.
And when you say so early in the universe, can you help people understand what that means?
Right. So in our standard cosmology picture, there was a Big Bang, and then the universe started cooling very rapidly following the expansion of the universe. And then things started to basically fall out of what used to be just all energy and light into matter as we see. And it happened several 100,000 years after the Big Bang. So initially, there really wasn't much happening. And then we think the first galaxy showed up sometime like 300 or 400 million years after the Big Bang. We are seeing this galaxy when the universe was 1.2 billion years.
Wow.
So in cosmological time, right now we're about 14 billion years after the Big Bang. So it was really right after things started showing up. It's just that we were expecting things to slowly build up into big things, but this thing just showed up. And they're a little more common than people expected. So at the moment, seeing something exciting and new like this, just triggered us to think about, how did that happen? Where do we have to introduce new wrinkles in explaining how galaxies form?
Yeah. And so for you, when you and the team made this discovery, what was your reaction?
Oh, the usual, back slaps and let's go drink.
It was very exciting.
Oh, very exciting.
And as I understand it from what I read in some information that came out from UMass, you thought what you would see would be very sort of disordered and disorganized, but that wasn't the case, right?
That's right. Yeah, so I was thinking, coming here, trying to draw some analogy. If you want to do something really big, you do either from the government, top down, pouring lots of money together, and then build something up, or you can do at the very grassroots level. Everybody get involved and chip in their little 2 cents, and then gather that into something bigger. Well, the way the cosmology works, there wasn't something big that would to start this off. So you had to start from the bottom, and sometimes grassroots movements can move fast and accumulate a lot of wealth and resources if people are well focused. I imagine something like that can happen, but usually those processes can be very chaotic. Everybody's basically bringing stuff over and just piling up rather than building a nice pyramid or something. So we would expect that if a process like that was happening early in the universe, we thought it would be just things pouring into a very special spot in the universe. So we naturally expected it to be just in a pile of things rather than really neatly organized, beautiful disk, which we are seeing in this particular case.
And so when you're looking at those disks, What does that, or does it help you understand, new things about your field?
Absolutely. One of the questions about this kind of galaxy that when we first discovered it and had no details was, how is it so bright? Not only accumulated so much mass, but it's turning all that mass into stars at a rate so fast that in fact it'll essentially turn into a bunch of old stars and ashes. And that, again, takes essentially a blink of an eye in cosmological terms, about 100 million years.
Just a blink of an eye.
Just a blink of an eye. So catching that in that moment is very special. But the way physics works is that when you try to accumulate any bit of gas, it turns into stars immediately. I mean, nature just knows how to produce stars. Otherwise, we wouldn't be here. But somehow in this particular galaxy, it waited and waited and waited until it gathered essentially 10 times the amount of gas that Milky Way galaxy has. And then it decided to essentially go into a burst.
Wow.
And we don't really know how that happens. And
Still working on figuring that out.
Oh, I'm going to spend the rest of my career trying to figure out how that happens.
And so this galaxy, the name is the Cosmos Aztecs 1 galaxy. Say that three times fast.
Right.
And as you say, it's forming at this rate that's 1,000 times faster than you thought.
Yep.
But how do you go about determining that, how fast it's moving?
It's a combination of knowing how far it is. That required some special instrumentation that we had to build. And then measuring all of its light in all wavelengths, from radio wavelength all the way to X-ray, and adding up all the light and figure out how much light is coming out of this galaxy. And so far as we can tell, it's all coming from young stars.
Wow. And so in science, in astronomy, we often hear that, okay, we thought X, Y, or Z, but now we think something different. So here,
Right.
obviously, you're thinking something different. How can you be sure that you're correct?
One thing I really love about science is that when we have facts, I don't particularly believe my own theory about the facts, but I trust the facts. So we're sure about the facts. That much we're sure about. Interpretations and my wonders about how could this have happened? Well, in some ways, it's just a part of the story. And some bright person, who may be a student of mine or somebody else's will come along and show me, what happened is something different, but that'll be okay. But what I know is that the fact that there is such a galaxy with such luminosity and mass at such early in time, we're absolutely sure about it.
And so what's the significance of having found this now?
Having found now is it began to answer some questions we had about some unusual galaxies we find in the local universe. Because this is a flow in time. So what we see today should be related to what we saw last year, 10 years ago, last millennia. So it's a continuation. So when we find something big and difficult to explain today, there had to be some explanation or some predecessor in time we can look back and locate. So there are some questions about when galaxies were actually formed and when they were put together and how they grow up to be where they are today. This is one of the hottest and very exciting topic of research in astronomy today. And this is what Hubble Space Telescope has done for us. And NASA's successes in building all the new observatories is answering this question. And we're putting together a nice story. That story began to develop real twist about 10 years ago when this type of galaxy was being discovered. And NASA began to launch some infrared telescopes that can see optically invisible galaxies. And we see them actually a lot more than we'd ever expected.